All right, 4.1, angles and their measures. So the first problems that we're going to do are DMS, so degrees, minutes, seconds, to decimal. So decimal would be the way that you have typically seen them written. Okay, DMS is going to be something new. I don't even think it's in the Algebra 2 book. But to start with, we've got 35 degrees, 24 minutes. So the conversion is the same conversion rate, like how many minutes are in an hour. Like it's the same thing. So what we do is we take the number of degrees. Okay, we're trying to go degrees, minutes, seconds to decimal, so that's going to stay. So 35 degrees plus, then we take the minutes and we do that divided by 60. And that's going to be degrees, and then whatever that number is, it should give us one decimal place.
0.4.
So 35.4 degrees. Then 48 degrees, 30 minutes, 36 seconds. So, again, works the same way. 48 degrees plus 30 over 60 plus, that's minutes. So seconds is going to be the conversion, like how many seconds are an hour, to help you remember. So 36 over 3600. And so each of these things, so minutes are going to give you the first decimal place, seconds are going to give you the second decimal place when you do the problem.
I'm just going to throw out 48.21 degrees. 251.
I was going to say, it's not 2. 48.51 degrees.
Apologies. I was looking at the 30 over 60 and 1 over 2, and then I pulled that 2 out of the denominator.
Why 3,600?
Because that, well, it's a conversion factor, but it's how many, basically for seconds, we have to convert it to minutes and then minutes to degrees. So it's kind of like, it's the same conversion, like how many seconds are in an hour.
Okay.
That's not why, but it's the same. It's what it is.
Kind of.
Yeah, so the seconds one will always be divided by 3,600. The minutes will always be divided by 60.
Oh, okay. So
Because there's 60 seconds in a minute, and there's 60 minutes in a degree, is what the official conversion is.
So it's just pure.
It's just easier to think about it in terms of time. Yeah. So whatever they give you here goes on top, and then the bottom is that conversion rate,
Okay.
just like we would normally do with time. All right, let's go the opposite way. Decimal to DMS. Uh, 49.7 degrees. So, the 49 part, that stays, okay? Anything in front of the decimal is always going to stay. That's just going to be just like the degree part up here, okay? So, we're working backwards. So, we take this 0.7, okay? Now, the first decimal place is always minutes. So, it's going to be 0.7 degrees times, there's 60 minutes in 1 degree. So, that's the official conversion factor. So the degree symbols, units cancel. So I have 0.7 times 60. That'll give me my minutes.
42.
42, so that's 42 minutes. So then our final answer is 49 degrees, 42 minutes. All right, next one. 99.37 degrees. Now, people tend to get confused and decide, oh, I'm just going to do the 0.3 times 60 and then 0.7 times 3600, okay? But what we actually need to do is do the 0.37 times 60 first to convert to minutes. If there is a decimal on my minute, so like with this last one, if it had been 42.7, then we would have taken that 0.7 and converted it to seconds, okay? So this is going to be 0.37 degrees times 60 minutes in 1 degree. So this is 22.2 minutes. So now, because I saw the decimal there, I can't have that. I'm going to take this 0.2 and multiply it, this is now minutes, by 60 seconds in 1 minute. So then we have 12 seconds. So when I write my final answer, then I have 99 degrees, 22 minutes. We drop that decimal point off, 12 seconds for our answer. So my suspicion in regards to the AP exam is when we get to solving trig equations and it says like what's the angle of blah 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 or whatever, that at that point they may say write your answer in DMS form, which would be this way. So that's why I'm telling you we're learning this, because not that I think you're going to have a question that's multiple choice that says convert this to DMS, but I think you could have a word problem that wants it in this form, or just even a notation in a word problem of multiple choice potentially. So
So if we didn't have like the 0.2, would that just be the end of the problem?
yes, yep. But most of the time, when you see the 2 decimal places, it's going to keep going. Because pretty much this clues you in that it's going to be minutes and seconds because of like what we did up here. Like when we were working the opposite way. We got that second decimal point from the last part. But not always the case, but I would say most of the time that's what's going to happen. All right, next thing is the conversion from radians to degrees. They don't have you convert degrees to radians, but it's just the opposite factor, so I think we're probably pretty good on that. 23 pi over 5. So remember, the most common thing is people trying to write the 3 pi over 5 all in the top, but what we actually need to do is just extend this out like this to do our conversion. And then we're going to have 180 over pi so that our pi's will cancel. And then we try to reduce it to leave it, if possible, or wait, never mind. We're not reducing it because it's pi. We're just getting a number. I've been teaching the other method in algebra 2. It's like yeah. Anyways, so how many degrees is this? 108. I feel like we're probably okay with it when they look like this. I mean, as long as you know the conversion factor, I think we're probably good. But something that's different than what we would have seen before is sometimes they give you your radians as something that looks like that. Now, if the instructions hadn't told us that we were converting radians to degrees, okay, they would have had to write RAD or write, like, written actually, like, radians after it for you to know what the units were on it, because otherwise it's pointless because you don't know what it is. But they told us it was radians, so we're still using the same conversion factor of 180 over pi, because pi is radians. We just don't ever write it because the pi clues us in that it's radians. So when you do this, you'll have to multiply 1.3 times 180 and then divide by pi.
74.48.
Yep. Now, just as a refresher, okay, if you were given, and just to do it a little differently, if you were given something in reverse like 166 degrees, okay, and we wanted to convert that, we would have pi over 180. Now, in the past, we've had nice even numbers, and so we've said just reduce and leave the pi in it, okay? But these aren't, well, they are both even numbers. They're not nice even numbers that are going to come out to something that, like, cancels out nicely. So we're going to actually multiply 166 times pi and divide by 180, and then get our answer. One decimal place is fine if it goes out more than that. .9. Now, because it doesn't have the pi symbol in it, indicating that it's radians, I need to write that on there to signify that it is in radians. Now, the book doesn't do the conversions from degrees to radians, but we've done it before. I just wanted you to see what happens if it's not a nice even number, because that can come up now, obviously. We'll pick up tomorrow with arc length and area. We might even look at, I don't know what that is. I don't know where that problem even came from. But how to convert from if you were given, I see it. Converting DMS to radians, so we'll look at that tomorrow as well. I kind of skipped that and do it out of order because of the way that, anyways. But it'll be using the stuff that we just did in combination with these conversions to be able to do that. And that more or less wraps this up. We might look at 1 or 2 word problems out of this section, and then, so we should be able to wrap this up tomorrow.